Hello everyone, and welcome to the first video for Math 150. This first unit will be basic concepts of algebra, or skills that we'll need for the rest of the class. Unit 1.1 is on algebraic expressions, and one of the biggest objectives today is just to be able to evaluate and simplify them. The next objective is to find the intersection and union of two sets, which by the end of this lesson you'll know what those words mean. And the final objective is to recognize subsets of real numbers, which is just a fancy way of saying, can you classify numbers? So let's just jump right into it. When we simplify algebraic expressions, we want to make sure we follow the order of operations so that we do things in the correct order. So a way to remember that is PEMDAS, which you probably have heard of before. Each letter stands for a certain operation that should be performed. So the first letter, P, is for parentheses. And I'm also going to put here brackets. They don't have to be parentheses. Basically, anything inside of grouping symbols should be done first. That's where your focus should shift. After that, we want to tackle exponents. Anything raised to an exponent. And then the final four things are the four operations themselves. So M stands for multiply, and D stands for divide. If both multiplication and division are in the problem at the same time, then a good rule of thumb is to do them in order from left to right, like you're reading a book. And then the operations that should be saved for the very end are addition and subtraction. And again, if they both appear in the problem at the same time, just like with multiplying and dividing, we want to do them in order from left to right. So let's try an example. Evaluate this expression when x equals 6. Anytime in math when you see the word evaluate, that means at the end we are going to have a numerical answer, like 10 or 50,000 or 2.5. So I'm going to take my expression, 7 plus 5, but instead of this unknown variable x, I'm going to replace it with what they said. So I'm going to replace x with 6. And then everything else is staying what it was. And now I just want to simplify this. So if we wanted to simplify this, we'd follow our order of operations, PEMDAS. And notice I have parentheses. So I want to tackle the information in the parentheses first. So 6 minus 4 would be 2. Okay, so now we have to decide, do we tackle the addition, the multiplication, or the exponent next? Well, according to PEMDAS, the thing that would have to come next is the exponent. So 2 cubed, which is like 2 times 2 times 2, would be 8. And every once in a while, this very last step is where I will see people slip up. The question is, do we do 7 plus 5 and then times by 8, or do we do 5 times 8 and then add the 7? According to PEMDAS, multiplication and division should come next. So I actually want to do 5 times 8. And then the thing that happens at the very end is the addition. So I get an answer of 47. So hopefully those problems aren't too bad. Again, if you see the word evaluate, that means you should have a numerical answer at the end, a value. Moving on, a lot of the times in this class we will be dealing with sets of numbers. So if I'm talking about a set, all that is in the math world, it's a collection of objects. And in our case, each of these objects is going to be referred to as an element. Example. Okay, I can't draw these to save my life, but they look like curvy brackets. If I saw something like this, this is a set of numbers, and I would say it has 4 elements. It has 4 things in it. Okay, so it's fancy notation for something that's not fancy. It's just a group or a collection of answers. So when we talk about sets, there's different ways that we can combine sets together. The first way is called the intersection. So let's say I have 2 sets, set A and set B. So I'm going to draw a picture here. So let's say this circle represents set A. And let's say we have another circle, and that's set B. If I want the intersection of these 2 sets, that's this. It's the region that they share, their overlap. So I'm going to say the intersection of sets A and B is the set of elements common to both A and B. It's what they share. It's the overlap. Now, in the math world, they use a symbol for intersection. So if I have set A and I have set B, if you see this symbol, it looks like an upside down U. That means intersection. We'll do an example in just a moment so you can really get an idea of what this means. So what if we have 2 sets that have nothing in common? They don't share anything. Well, then we will often have what's called an empty or a null set. And this is a set with no elements in it. It's empty. The symbol for this empty set looks like a circle with a slash through it. So let's try an example here so it hopefully makes more sense. Find the intersection of these 2 sets. And I know I want the intersection because notice my little upside down horseshoe. So my answer is going to be a set. And in this set, I only want to list the numbers that are common to both of the original sets. So if I look at this one had 7, but the other one didn't have 7, so I don't want to list 7. They both have an 8 though, so I'm going to list an 8. They both don't have 9. Oh, they both have 10. They both don't have 11. So this is the answer. This is the intersection. It's what they have in common. A lot of the times in math, this is important because we're going to be looking at common things that 2 either equations or functions or sets have in common, because sometimes that'll help with simplifying. Let's try the next one. Find the intersection of those 2 sets. If you want, you could even pause the video, answer it, and then see if you match up with me. Let's see here. They don't share 2. They don't share 4. They don't share anything in common. So we would say this answer is the empty set. They don't have anything in common whatsoever. That would be like if I did a picture like I did up top. This would be set A. This would be set B. They're totally separate. They do not overlap at all. Okay. One other way that we can combine sets together is the union. So this, if I drew a picture again, if I have my 2 sets, A and B, the union of the sets in A or B, it's like I can have the numbers in A, I can have the numbers in B, or I can have it in both of them. So it's like, think of the word or itself. If I want this or that, I don't care which one. It doesn't matter to me. So the union is like everything. Or think of it like a marriage. If 2 people are united, all of their possessions are now all of their possessions. Everything together. In math, the symbol for union, and we're going to be running into this guy a lot, looks like a U. And that's kind of easy to remember because U and union. So let's try this example, and now I see that I have a typo here, so make sure to fix this. If I want the union, we would see the upside down, or the regular U, not the upside down one, so make sure to fix that. So my answer, let's see here. I want the set of numbers that they have in common completely. So notice the right one has a 6, but the left one doesn't. I don't care. I'm combining everything together. The left one has a 7, but the right one doesn't. I don't care. It's going to be in the union. They both have an 8, so great. There's a 9, there's a 10, there's 11, and there's a 12. So the union is literally everything together, united. I would prefer when you write these that they're in numerical order, but it doesn't really matter. Make sure when you type these in online, when you do the homework assignment, it does want the commas listed, so you will have to type a comma. Okay, so that is the union. One of my students from previous years had a crafty way of remembering how to keep these straight. Union looks like a U, and if I go back, what they have in common, he said, oh, it's like in common or n common. He's kind of did a play on words. It kind of looks like an N. I don't know if that'll help, but it seemed to help him quite a bit. Our next objective is classifying numbers. So I have this handy little guide which I really think helps classify them. So they needed a way to kind of organize numbers, kind of like if you think of dogs, we have the category of dog, and then I can break it down even more specific into types of breed. That's kind of what we're doing here with numbers. So the big overall category are the real numbers. That's the big category. And then within the real numbers, my first breakdown, they can either be rational or irrational. Rational numbers can be written as fractions, or they can be written as decimals. However, when they're written as decimals, they either repeat themselves at some point or they terminate, which means they have to end. So an example of a rational number could be, I don't know, 5.28. Yes, it's a decimal, but it does stop. Another example of a rational number could be 1.3 repeating. Yes, it's a decimal, it repeats, that's okay. Irrational is the exact opposite. They cannot be expressed as a fraction, and as a decimal, they never stop, but they never repeat themselves. Probably the most famous irrational number is the number pi. Gosh, I don't even know. They still haven't found the end to it. As a decimal, it's 3.1415, blah, 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 blah. They haven't found a spot where it repeats itself yet, and it hasn't reached an ending point. Another example of an irrational number could be square root 7. If you were to do that in the calculator, you'll get this decimal, and this decimal doesn't stop and it doesn't repeat itself. It just goes on forever. An example of a rational number could be square root 9, because even though it's a square root, the square root of 9 is 3, which stops. Okay, now we can get even more specific. If I break down rational numbers further, we have the integers. Integers are negative numbers, 0, and positive numbers. And I'll do ... showing that I could keep listing them. So notice integers do not include fractions and they do not include decimals. They're more specific. Every time I move down in this box, I'm going to get more specific with my numbers. So then moving on, whole numbers are 0 on up. So whole numbers do not include negatives. And then finally, the natural numbers are even more specific. They are sometimes called the, whoa, I don't know what happened there. They are sometimes called the counting numbers, and they are 1, 2, 3 onwards. So they do not include 0, because usually when you count, you don't start at 0, you start at 1. All right, so let's try this. Let's see if we can actually organize numbers here. So I've given you a set of numbers, and it has 1, 2, 3, 4, 5, 6, 7, 8 elements in it. And I want us to place these into the correct categories. So list all the natural numbers. So I want to take all these numbers that could be considered natural numbers. So remember, natural numbers are 1, 2 on up, right? They don't include 0. So do I have any numbers up here that would work? Well, not -7, not the fraction, not 0, not the decimal. Square root 5 is a decimal, not pi, not the decimal. Square root 81 is actually equal to 9. So yes, we would want to list that. That is a natural number. It's 9. Okay, now let's do whole numbers. Whole numbers include 0 on up. Well, we do have 0 in our list, so we'll include that. And square root 81 is a whole number. It's 9. Okay, the integers. According to our chart, the integers are negative numbers, 0, and positive numbers, but no decimals or fractions. So -7 could be listed, not the fraction, -3/4. 0, not the decimal, not square root 5, not pi, not the decimal, and square root 81 is also an integer because it's 9. So notice square root 81 has fit into all 3 of these categories, and it makes sense if you think about it. If I look at this chart, if my number falls into the natural numbers, then it's all of these categories as well, right? Like a bulldog is a bulldog, but it's also a dog. It fits into the larger category. Okay, rational numbers. These are the numbers that can be written as fractions or decimals. So -7, because if I really wanted to, I could write that as -14/2. That's a fraction. -3/4, 0, 0.6 repeating, not square root 5, because as a decimal that doesn't stop, not pi, same reason, 7.3, and square root 81. Those would all be rational numbers. Irrational numbers cannot be written as fractions and as decimals. They never stop and they don't repeat. So square root 5 and pi. They are the, I guess we could call them the not nice numbers. And then real numbers, this is the biggest category. And I'm going to be lazy here, and it's all of them. All of those are real numbers. So the real numbers is the biggest category. It should include the most things. All right, the final objective here is to just practice simplifying expressions. So if we're simplifying, chances are good we won't have a numerical answer. We're still going to have some variables left. So if I simplify, notice inside the parentheses, I cannot combine those because one of them is x squared and one of them is just an x. But we can distribute. So I'm going to multiply in 6 times 2x squared. If I had 6 of those, I would have 12x squareds. And 6 times 4x, I'd have 24x's. If I do the same thing on the other guy, 10 4x squareds would be 40x squared, and 10 3x's would be 30x. I'm just multiplying and distributing. And the last step would be to combine like terms. So I'm going to combine my x squareds. If I have 12 of them and 40 of them, I now have 52 of them. If I have 24x's and 30x's, I now have 54 of them. I cannot combine those together because they are not like terms. They would either both need to be x squareds or both x's. And the last one here, let's work our way inside out. So here, x minus 3, I have this negative out front that I'm going to send through. So I have 8x plus 2, and then I have 5 minus x plus 3. Negative times x would be negative x. Negative times negative 3 would be plus 3. Now notice in here I can combine like terms. I have a 5 plus 3. So 8. And then I'm going to distribute the 2. So 2 times 8 and 2 times the negative x. And then we'll combine like terms. So 8x and the 2x can be combined. So 8x minus 2x, 6x. Then I still have the plus 16. I cannot combine those. They are not like terms. So that's it for 1.1.